Hi everyone, today we're going to study cross or vector product. The vector product or cross product of two vectors A and B denoted by vector A times vector B and is defined as vector A times vector B equals the quantity length of A times length of B times the sine theta. This theta is the angle between the two vectors. And this quantity is multiplied by a component n, where this component n is the unit vector perpendicular to both A and B. This illustration will help us understand our cross product. This is the vector A and this is the vector B. This is the theta, the angle between the two vectors. Now, this A times B, this is what we call the resultant vector. And we say that the resultant vector, that is vector A times vector B, is perpendicular to both vector A and vector B. Now, let us calculate vector A times vector B using determinants. If vector A equals a sub 1 I plus a sub 2 j plus a sub 3 k, and vector B equals b sub 1 I plus b sub 2 j plus b sub 3 k, then vector A times vector B, we will get a 3 by 3 matrix. The first row here are the elements for the components I, j, and k respectively. The middle row, these are the coefficients of vector A. So we have this a sub 1, a sub 2, a sub 3. The last row are the coefficients for vector B. So we have b sub 1, b sub 2, b sub 3. Now using determinants, we will have like this. This is element I multiplied by the square matrix a sub 2, a sub 3, b sub 2, b sub 3. Then minus the element j multiplied by the square matrix a sub 1, a sub 3, b sub 1, b sub 3. Then plus the element k multiplied by the square matrix a sub 1, a sub 2, b sub 1, b sub 2. Then we will just take the determinants for each of the square matrix, and it becomes like this. It means the I multiplied by this a sub 2 times b sub 3 minus a sub 3 times b sub 2. Then we copy the minus sign, we go to the next element j. That is now a sub 1 times b sub 3 minus a sub 3 times b sub 1. Then plus, we go to element k. A sub 1 times b sub 2 minus a sub 2 times b sub 1. Example 1. Find vector A times vector B if vector A equals I plus 2j plus k and vector B equals 3i minus 4j plus k. So we write here vector A times vector B, and let us write also the 3 by 3 matrix, and it is here. So in the first row we write I, j, k. The second row for the coefficients of vector A, 1, 2, 1 respectively. The last row is for the coefficients of vector B. So we write 3, negative 4, and 1 respectively. Now let us write I multiplied by the square matrix 2, 1, negative 4, 1. Then minus for the j multiplied by the square matrix 1, 1, 3, 1. Then plus the element k multiplied by the square matrix 1, 2, 3, and negative 4. Then let us evaluate the respective determinants. So we have this 2 times 1 is 2 minus negative 4 times 1 is negative 4. Then we copy the element I. Minus 1 times 1 is 1 minus 3 times 1 is 3. Then we copy the element j. Plus 1 times negative 4 is negative 4 minus 3 times 2 is 6. This is multiplied by the element k. Simplifying further, this 2 minus a negative 4, it becomes positive 6. Then we copy the I. 1 minus 3 will be negative 2. And because there is negative here, it becomes positive 2. Then we copy the j. Negative 4 minus 6 becomes negative 10. Then we attach the element k. This is now the final answer. Example 2. Find a vector perpendicular to vector A equals I plus 2j plus k and vector B equals negative I plus j minus k. We note that vector A times vector B is perpendicular to both vector A and vector B. So this problem is similar to finding the vector product of these two vectors. So we write here vector A times vector B equals the 3 by 3 matrix. The first row is for the elements I, j, k respectively. The middle row are the coefficients of vector A, that is 1, 2, 1 respectively. The last row are the coefficients of vector B. So we write here negative 1, 1, negative 1. Using our idea of determinants, we write now the element I multiplied by the matrix 2, 1, 1, negative 1. Then minus element j multiplied by the square matrix 1, 1, negative 1, negative 1. Plus element k multiplied by the square matrix 1, 2, negative 1, positive 1. Let us now evaluate the corresponding determinants. So for the I, we have 2 times negative 1, negative 2, minus 1 times 1 is 1. Then minus element j, and then this is 1 times negative 1, negative 1, minus negative 1 times 1 is negative 1. Then plus the element k, then we have this 1 times 1 is 1 minus negative 1 times 2, negative 2. Simplifying further, we have this negative 2 minus 1, so we write negative 3i. Then minus this negative 1 minus negative 1. This is simplified into negative 1 plus 1, and that would be 0. The 0 multiplied by j, this element j will be cancelled out. Then plus this 1 minus the negative 2. So it becomes 1 plus 2. We have positive 3 multiplied by element k. This is now the final answer. Today, we're going to study properties of cross product. We learned that given two vectors A and B, the cross product vector A times vector B is a resultant vector that is perpendicular to both vector A and vector B. This illustration will help us understand better this idea. Now, let's have here three vectors I, j, and k. In here it says that vector I is perpendicular to vector j and also perpendicular to vector k. It means one vector here is perpendicular to both of the other vectors, and this is true to all the vectors. Now, number one, if vector I times vector j, this is equal to the negative of the quantity vector j times vector I. And this is equal to the vector k. Number two, vector j times vector k. This is equal to the negative of the quantity vector k times vector j. And that is equal to vector I. Number 3, vector k times vector I is equal to the negative of the quantity vector I times vector k. That is equal to the vector j. Now let's have parallel vectors. Non-zero vectors A and B are parallel if and only if vector A times vector B equals 0. This is our working formula here. Second, vector I times vector I is equal to vector j times vector j, and also equal to vector k times vector k, and all of them are equal to 0. Number 3, 0 times vector I equals 0. Now, if vector A, vector B, and vector C are any vectors, and P, Q are scalars, then number 4, P times vector A times the quantity Q times vector B. This is equal to the quantity P times Q times the quantity vector A times vector B. Fifth, vector A times the sum of the quantity vector B plus vector C. This is equal to vector A times vector B plus the quantity vector A times vector C. The sixth, the sum of vector B plus vector C then multiplied by vector A. This is equal to vector B times vector A plus the quantity vector C times vector A. Today we're going to study parallel vectors. Non-zero vectors A and B are parallel if and only if vector A times vector B equals 0. Example, prove whether the vectors A equals 5i minus j plus k and B equals negative 15i plus 3j minus 3k are parallel or not. We will show that vector A times vector B equals 0, so that the two vectors here are parallel. So let us solve vector A times vector B. Let us write the 3 by 3 matrix. First row, I, j, k. Second row, 5, negative 1, 1. These are coefficients of components of vector A. Third row, negative 15, 3, negative 3. These are the coefficients of the components of vector B. Now let us solve for the determinants. So we write I times the square matrix negative 1, 1, 3, negative 3 respectively. Then minus component J times the square matrix 5, 1, negative 15, negative 3 respectively, plus component K times the square matrix 5, negative 1, negative 15, 3 respectively. Let us now evaluate the determinants. So I is multiplied by the quantity negative 1 times negative 3, that is positive 3, minus 3 times 1 is 3, minus component J times the quantity 5 times negative 3 is negative 15, minus negative 15 times 1 is negative 15, then plus component K multiplied by the quantity 5 times 3 is 15, minus negative 15 times negative 1 is positive 15. Simplifying the terms in the grouping symbol, 3 minus 3 is 0 times I, minus negative 15 minus negative 15 is 0 times J, plus 15 minus 15 is 0 times component K. Because of the zeros, the vector here equals 0. And we write, since vector A times vector B equals 0, then the two vectors are parallel. Today we're going to study magnitude of cross product as area of parallelogram. So we use the symbol here, the magnitude of vector A times vector B as area of parallelogram. Given a parallelogram, we assign some values, so the base is the vector A, the side here is the vector B, and we assign this angle here to be angle theta. Now let us assign the height h. From the right triangle form, we can say that sine theta equals h, or the height, all over the magnitude of vector B. Manipulating this, we will get the value of h equals the length of vector B times sine theta. Now for the area of parallelogram, that is equal to base times height. Looking at our figure, the base here is the vector A, and the height h, that the value is in here. Let us substitute the corresponding values. So we have here the length of vector A times the length of vector B times the length of sine theta. So by definition of cross product, we can simplify this expression into the magnitude or length of vector A times vector B. This is now our working formula. Example, find the area of a parallelogram with adjacent sides. Vector A equals I plus 2j plus k, and vector B equals negative I plus j minus k. Let us write our formula for the area of parallelogram, and it's here now. So for step 1, let us first evaluate vector A times vector B. We write our 3 by 3 matrix respectively. So we have I, j, k for the first row. Second row is the 1, 2, 1, these are the coefficients of the components of vector A. The last row, negative 1, 1, negative 1. The coefficients of components of vector B. By the definition of determinants, we'll have component I times the square matrix 2, 1, 1, negative 1 minus component J times the square matrix 1, 1, negative 1, negative 1 plus component K times the square matrix 1, 2, negative 1, 1. Evaluating the determinants, we have now component I times the quantity 2 times negative 1 is negative 2 minus 1 times 1 is 1. Then minus component J times the quantity 1 times negative 1 is negative 1 minus negative 1 times 1 is negative 1 plus component K times the quantity 1 times 1 is 1 minus negative 1 times 2 is negative 2. Simplifying further, negative 2 minus 1 will be negative 3 times I. So we have 3I minus component J times negative 1 minus negative 1. So we can cancel this because this becomes negative 1 plus 1. Component J is deleted plus component K times 1 minus negative 2. So it becomes 3K and we copy it here. This is now the cross product vector A times vector B. Now for step 2, let us evaluate the length of vector A times vector B. Our formula is this big square root x squared plus y squared plus z squared. The values x, y, z are coefficients of the components I, j, k respectively. Evaluating the corresponding values, we have now the big square root of coefficient of I, that is negative 3, and we put a square, plus there is no j here. It means coefficient is 0. Then we put the square, plus coefficient of k, which is 3, we write here 3 square. Simplifying further, we have now the big square root of 9 plus 9. We can simplify this further into 3 square root of 2. And since this is an area, we write square units. This is now the final answer. I hope you learned something from this video. See you again next time.